Hello, my name is Kanji Frank. I might be presenting this coursework on cache memory mapping functions and replacement algorithms. Cache memory mapping functions refer to the techniques used to determine how data is stored and retrieved in a cache memory. Each of these mapping functions has its own advantages and trade-offs in terms of speed, complexity, and efficiency in utilizing cache space. The choice of mapping function depends on the specific requirements and constraints of the system architecture. There are three main types of cache mapping. The first one is direct mapping. In this method, each block of main memory can be mapped to only one specific cache location. The cache location is determined by taking the least significant bits of the memory address. This means that a particular block of memory will always be stored in a specific cache location. The second one is associative mapping. This method allows a block of main memory to be loaded into any cache location. The cache controller determines where to place the block based on the context of the memory address. This offers more flexibility compared to direct mapping, but requires additional hardware to search the cache for a matching address. The third option is set associative mapping. This is a compromise between direct and associative mapping. It divides the cache into a number of sets, each capable of holding multiple blocks. A specific block from main memory can be mapped to any one of the blocks in a specific set. The cache controller decides which set to use based on a portion of the memory address. Now let's talk about cache memory replacement algorithms. Cache memory replacement algorithms are techniques used by cache management systems to decide which data to remove from the cache when it is full and new data needs to be loaded. Different applications and scenarios may benefit from different replacement algorithms, depending on the access patterns of this data. Each algorithm has its trade-offs in terms of complexity and efficiency. Here are some common cache replacement algorithms. The first one is last recently used. This algorithm removes the least recently used item first. It keeps track of the order in which the data is accessed, and when the cache is full, it removes the item that hasn't been used for the longest time. The second one is first in, first out. This algorithm removes the oldest item first. It works like a queue, where the item that has been in the cache the longest is the first to be replaced. The third one is random replacement. This algorithm selects a random item for replacement. It's simple but may not be the most efficient, as it doesn't consider the access pattern of the data. The fourth one is the least frequently used. This algorithm removes the least frequently used item. It keeps track of how many times each item is accessed, and then when the cache is full, it removes the item with the lowest access count. The fifth one is most recently used. This algorithm removes the most recently used item. It keeps track of the order in which data is accessed, but unlike the last recently used, it removes the most recently accessed item. The sixth one is the not recently used algorithm. This algorithm classifies items as recently used or not recently used based on their access status. When the cache is full, it removes an item from the not recently used category. The seventh one is the optimal replacement. This is a theoretical algorithm that removes the item that will not be used for the longest time in the future. It requires knowledge of the future access patterns, which is not feasible in practice. So that's the end of the presentation.